Hello, everybody, and welcome to Earth Sky's Monday livestream. I'm Will Triggs, and I am delighted to say I have planetary scientist Alan Stern with me. I'm sure many of you will know Alan. He served as Chief of Science at NASA. He was the man behind the New Horizons mission to Pluto, and he's recently produced some very interesting research on the Fermi Paradox. Welcome, Alan.
Thanks, Will. It's great to be here. Happy
It is
Monday
so
to
great
you.
to have you. And, well, I think we have to get straight into it. What is the Fermi Paradox, and how have people tried to solve it?
Well, the Fermi Paradox, which is named after Enrico Fermi, the Nobel laureate physicist, mid 20th century guy, has to do with the search for extraterrestrial life. And as the story goes, way back in 1960 or 61, Fermi was attending a small workshop with Frank Drake and Carl Sagan and others who were really ahead of their time in starting to think about how you would actually search for extraterrestrial intelligence. And apparently, the lunchtime conversation came to the Drake equation, which is about it's a recipe for computing estimates of how many civilizations might be communicating in the universe. And because the Drake equation is full of unknowns, you can get almost any answer you want. But you
Hmm.
can also, among the answers that are plausible, are extremely large numbers of communicating extraterrestrial civilizations. And in hearing about that, Fermi said something like, if there's so many, then where the heck are they all? Why don't we see any evidence of them? Why aren't they all around us? At least in terms of communication. And that question has been dubbed the Fermi paradox ever since back then in the early 1960s. And in that long span of time since then, many ideas have been put forth in the scientific literature that attempt to explain it. They fall into various categories. One category, for example, is that they communicate in ways that we're not aware of, or maybe we haven't developed yet. Another is that there just aren't very many technological civilizations, or that they develop very often, but their lifetimes are typically short. They snuff themselves out, um, say by nuclear war or by global environmental catastrophes, or we might say today because the AI takes over. Uh, so there are all
Hmm.
these different ideas. In fact, there are close to 100 ideas that have been published. And I only get credit for adding one more to the list. Nobody knows which one or ones are going to turn out to be correct, but have fun thinking about a new way to think about the problem.
Right, because it's, as you say, it's been a long problem. We've had this around for 60 years, and we have no real answer, right? And some of the answers are scarier than others, and we don't know where we lie in this whole thing. But you have come up with a potential answer to, solve some of these questions. So tell us about your potential answer to the Fermi paradox.
Well, Will, this is not meant to be the end all. It's just meant to be another contribution, another brick in the wall, if you will, into
Hmm.
thinking about this. But one of the revolutions in planetary science, which is my field, one of the revolutions that's taken place during my career has been the realization that ocean worlds are common in our solar system. And, in mid century, just at the dawn of the space age, when astronomers looked out before spaceflight and used ground based telescopes to look around the solar system at the terrestrial planets, the moons of the giant planets, all the solid surfaces. Um, they looked and they couldn't find any analog to the Earth. They couldn't find another ocean world and concluded that there were no other worlds with oceans in our solar system.
Right.
Um, Later, starting in the 1990s, evidence started to build that there are oceans elsewhere in the solar system, but they're not visible by telescope because they lie beneath um, large columns of ice or rock and ice in the outer solar system. And the first evidence came with Jupiter's moon Europa, uh, which is a little bit smaller than our moon, but which we now have definitive evidence of global subterranean, if you will, ocean uh,
Hmm.
there. We now found more evidence, again, direct evidence, at Enceladus, which is a moon of Saturn's that was studied extensively by the Cassini spacecraft that NASA sent to Saturn. And there is pretty good evidence for a half a dozen, at least a half a dozen other worlds in the solar system that may have these kinds of deep underground oceans. They are primarily icy satellites of the giant planets, all the way out to Uranus and Neptune, but also Pluto, which New Horizons explored, has a very good chance of having a subterranean ocean, and probably other Kuiper Belt worlds as well. So um, those mid 20th century astronomers were both right and wrong when they looked across the solar system and couldn't see any other oceans. They were right. There are no other oceans that are visible on the surfaces of worlds in our solar system. But it didn't enter into their thinking that there might be these global subterranean oceans. Now we know that they're
Yeah.
pretty common. In fact, they way outnumber the one weirdo world of the Earth that
Yeah.
where its oceans on the outside. And it occurred to me in thinking about this revolution and the fact that there are biologically interesting aspects to these oceans, that they're better protected from things like impacts and supernovae and other external hazards, and that they are a way of expanding our way of thinking about what is a habitable zone. You don't have to be near your star. A world like Pluto, very, very far away, can have a warm liquid water ocean in it. In fact, even worlds across the galaxy that don't even belong to stars might have oceans like this. And so my contribution is in simply recognizing that if somehow, and there are many steps in the chain that are not yet fact, but if somehow these biologically interesting, astrobiologically interesting places, these ocean worlds, can not only develop life, but develop intelligent life or even civilizations, that they might way outnumber uh, those on the surfaces of worlds where the hazards are greater. And the interesting thing, and here's the clincher of how it relates to the Fermi paradox, is because they are beneath kilometers, or in some cases, tens of kilometers of rock and ice, they can't communicate. We would not see evidence of them. They are sort of inherently stealthy. There's some other implications, but I don't want to go on too long. But basically, my contribution to the Fermi paradox is to say, think about the implications of the very common situation of subterranean ocean worlds and how that might relate. There might be many civilizations, um, but they can't communicate with one another. With us, we would have no evidence of them directly, uh, and that would answer Dr. Fermi's question, wouldn't it?
Yeah.
Because
It's an
they're
incredible
out
thing to
there.
think
They're
about.
just not
Yeah.
communicating because they're beneath these big lids of rock and ice.
Yeah. And it just goes back to it's a tale as old as time. The issue is we struggle to think about life that doesn't look like us. We think you have to live on the surface and you have to have
Right.
tectonics, and it just maybe isn't true. And it's interesting what you said about habitable zones, because I think when I was growing up, that was, kind of the Goldilocks zone was this big thing that we learned about that had to be. We were looking at exoplanets as well. There has to be the habitable zone where there's liquid water, and it looks like that's not true. And it also looks like maybe planets aren't the place to look. It's more about satellites, maybe further out of the solar system. So does that change how we look for life if we are, really dedicated to looking for life in the solar system? Well, not in the solar system, but beyond the solar system.
You're
How would
right.
you look for this now?
Our own biases are what have shaped us. And before we could imagine these global subterranean ocean worlds, we only thought about habitable zones as those planets that were at the Goldilocks distance, not too close and not too far from their star, where liquid water could persist. And many people started pointing out that there were all kinds of hazards to these situations. You need a magnetic field to protect you on the surface from some kinds of charged particles and lethal radiation, for example. And you need to be on a planet that doesn't get too many giant impacts of the sort that were dinosaur killers, and so forth and so on. And it's people started to get pretty pessimistic. But with this new thinking about subterranean ocean worlds, it's really opened up our thinking about where the habitable zones could be, as I said, even to the extent that they don't have to be on worlds that are much less in a classical habitable zone. They don't even have to be worlds that are attached to stars at all, because you could have these kind of oceans, perhaps, in free floater planets that orbit in the Milky Way that have been lost from their stars. It's mind boggling in
Right.
a way.
I mean, that is crazy, and I guess we have so little way of knowing how many of those rogue worlds there are, right? There's just another
Well, there are a lot of
untold
them in
number
our
in the
solar system, and we know that
right.
that, that many solar systems clean up. That is, that when large planets form, that they muscle everything else out. And in that process, from computer simulations, we know that the formation of Oort clouds and sending a lot of material, comet-sized, for example, out into the galaxy is common. We've seen interstellar comets now on a couple of occasions, and suspect that there are astronomically large numbers of them. But small planets and even large planets, planets the size of the Earth, can easily be ejected as well to these never lands between the stars. So again, it's mind-boggling. We're
Yeah.
still attached to the idea that intelligent life would arise on planets, and that may not be the only way it can happen either. But at least we're now less fixated on uh, life only being possible on the surface of worlds. So it is changing the way that we're looking for life. And NASA has done a lot of work thinking about habitable worlds in the outer solar system as a result of this, and just launched a major flagship planetary mission called Europa Clipper that launched just last month. I'm on that science team,
Yes.
and is headed to Europa, the moon of Jupiter, with a known ocean beneath its surface, and will arrive there in about 5.5 years' time to begin a very detailed battery of investigations to understand not whether there's life in that ocean, but the habitability, if the conditions are right for life. What is the chemistry of
Right.
the ocean? What's the extent to which it communicates with the surface, with geysers, or through other ways that the ocean might leak out, and we can actually sample it from space or on the surface, for example.
Yeah. And let's talk about Europa Clipper because that is such
Yeah.
an interesting mission. I think it's really capturing people. And there's lots of hope that I think we'll go to Europa and we'll find aliens or something. But obviously, we're not landing on the surface, right? It's not that kind of mission. So, what actual science is being done? What best case scenario, what might we find with the Europa Clipper?
Well, those are very different questions. The Clipper mission will go into orbit around Jupiter. And as uh, many who are listening here know, Jupiter has very intense radiation belts that are a hazard to our spacecraft because the radiation can scramble the electronics. So Europa Clipper was built to sustain um, traveling through that very hazardous radiation environment. But even Europa Clipper and the best technology that we can afford today doesn't allow us to put a spacecraft in orbit around Europa because it would perish from the lethal radiation in a matter of weeks or maybe a couple of months.
Wow.
So instead, what Clipper does is it enters orbit not around Europa, but Jupiter itself, and successively flies by Europa, making repeated studies many dozens of times. And on each study, um, uh, the 9 scientific instruments aboard that include everything from cameras to radars to mass spectrometers to ultraviolet and infrared spectrometers to dust analyzers, everything is trained on Europa to map its surface in detail, to understand what's coming out of the surface. It might be from within the ocean, to understand the depth of the ice layer, perhaps even how deep down the ocean is and where the ocean might communicate, to look for plumes of material that might be escaping, such as we saw in the Cassini mission at Saturn's moon Enceladus, in which
Right.
Cassini then flew through those plumes and discovered that the water coming out is not only, in fact, water and not something else, but salty water loaded with organics, even complex organics, and hydrogen sulfide, which is an indicator of perhaps hydrothermal vent systems. where we know that life has arisen in the deep ocean here of the Earth.
Yeah, and that's something I think we're always looking for. These again, it's similar to Earth. That's what we're looking for, but that's all we know, I suppose. Um, is there the way for Europa to do the same thing, fly through if we do find these vents? Can it then, test what it collects and
Perhaps
find?
it depends upon the details of the vents that we find, how high the material is lofted, whether the vents are sporadic or persistent. It's hard to plan if they're very sporadic to be
Right.
there at the right time. They have to get up high enough that we can safely conduct flybys. And so we'll have to see. But it's a mission of discovery. It's the first of its kind to an ocean world. And I think it's going to be mind boggling when we get it there. And now it's off not only to a safe launch, flying on a big SpaceX rocket, but now about a month in flight and things are going very well. Spacecraft checkouts are going well. Instrument checkouts have started. First trajectory correction maneuver to put it on target for a Mars flyby early next year, and then an Earth flyby to send it on its way to Jupiter in a couple of years. We're in good shape. It's early days, but the spacecraft's performing just as it should.
That's what we like to hear. That is that is good to hear. We've got a couple of questions in the chat, but before we get to those, I think we should talk about New Horizons as well. Whilst we're talking about these space missions,
Sure.
because obviously that is the classic mission that so many people fell in love with back in 2015. And thanks to that mission, we now know that even Pluto, way out in the outer solar system, has an ocean beneath its surface. Did that change our understanding of life in the universe? Was it just another brick in the wall of these ocean worlds, or did we find anything else more there?
Yeah. So we don't know that Pluto has an ocean the way that we do with Europa and Enceladus,
Hmm.
but we have uh, four or five very strong lines of circumstantial evidence. And I would put my bet on there being an ocean there. But what we really need is an orbiter, a subsequent mission to go back, follow up the single flyby that New Horizons could make, and really stay and bring the same kind of battery of instrumentation that Europa Clipper has to really understand that. The difference with what Pluto contributed to this thinking, and of course, New Horizons discovered many things beyond the ocean about Pluto, but with regard to the ocean, most of the ocean worlds that we're discovering, as we talked about earlier, are satellites of giant planets, like Europa and like Enceladus and like Triton and like Titan. And we can go on down the list. But many of those are in special situations where the energy required to create the ocean, to melt the ice, um, is created in a special circumstance. For example, in the case of Europa, in a tug of war between other large moons of Jupiter that actually heat Io and to a lesser extent Europa, Io being another one of the Galilean satellites. Pluto is out there all on its own. It's not a satellite of a giant planet. It's a planet its own right, orbiting in the Kuiper Belt, and doesn't have that external source of energy. And so finding an ocean there just opens up the possibilities even further that other small planets in the Kuiper Belt, like Eris or Makemake or Haumea, might themselves sport oceans, and that oceans might be quite common in Kuiper Belt planets. Wouldn't that be mind-boggling?
Right. It just adds so many layers to this equation. You mentioned the
It
Drake
does.
equation that is just it's a difficult one because there's so many variables, and obviously now that we know that oceans are important, how common are oceans? Are they more on moons and satellites? Someone has asked a question about this in the chat. Which term or terms in the Drake equation does the concept of deep ocean life change, and how?
Well, the Drake equation, for those who aren't familiar with it, is a half a dozen or so uh, factors. And it goes something like this. If you want to compute the number of habitable civilizations that are communicating at any given time, first you have to know the rate at which stars form. And then you have to know the fraction of stars that form planets. And then the fraction of planets that can support life. And then the fraction of those that can support life, which actually develop life, followed by the fraction that develop intelligent civilizations, followed by the fraction of those that actually come to communicate, either intentionally or accidentally, in the way that we were sending out radio and TV signals, not because we wanted to communicate across the galaxy, but we want to
Right.
communicate with one another, and those signals just propagate outward. You have to know all those things, and then you have to also know the typical lifetime of a civilization. Um, and the end result is to give you a number. And as I said, even back in 1960-ish, when Frank Drake invented the Drake equation, all the way to the present day, the estimates vary all over the place. From very pessimistic estimates that the number of communicating civilizations is precisely one, namely ours, to I've seen numbers as high as 10 to the 16th power, which is like 100 million billions in the
Big number.
universe. It's mind-boggling, right? Um, what uh, what the underground ocean concept does is it raises the probability, we think, could raise the probability of the number of worlds that can be habitable and which develop life and ultimately civilizations. Now, to cement that, to make it more than just scientific speculation, we're going to have Europa Clippers data sets, but also data sets from other kinds of missions that still aren't built, that we hope to build and fly in the mid and late 21st century, to get a better handle on all this. And of course, if Europa is promising from a habitability standpoint, a lot of people would like to see us go back to Europa and maybe try and get a craft down in the ocean, communicating with us back here on the Earth, something that looks more like a submersible or a submarine,
Right.
that can actually go look about for actual signs of life in that ocean.
How feasible do you think that is? What kind of timescale? Because it's a thick ocean, thick crust, right? It's like 10 kilometers or something like that.
It it may well be very, very deep, and it's hard to tunnel through that.
Hmm.
People have ideas for how you might, for example, generate heat and melt your way down. Of course, if
Right.
you run into a slab of, of rock, for example, that's floating in the ice, and which is much larger than your spacecraft, and you can't get around it, you could be stymied. So, what we're
Hmm.
hoping is that we will find fissures where we have direct access to the ocean, some sort of vents, or other places where the ice is very shallow, or where the ocean water actually comes out. And if it does, then we could imagine engineering craft to go down in those windows, if you will, into the oceans that are much simpler in terms of access, perhaps, than trying to drill down, thermally or otherwise, to the ocean. Whatever it is, it's something that we don't know how to do today with any real chance of engineering success, because we don't know enough about Europa's ice shell and how deep the ocean is and where those locales where we get access might be. But Clipper should tell us those things. And it's specifically
Right.
designed to try to get at that, so that we would have enough information to imagine what kind of craft we would have to build. Now, if it turns out, um, Clipper tells us it's too hard, Europa's the wrong place to look. We already know that Enceladus provides um, uh, access to its oceans through the vents that Cassini discovered and actually flew
Right.
through. And although it's twice as far away from the Earth, it might be that that's the next place that we go to try to get down in an ocean and see what happens in terms of the development of life.
Right. Is there anything that Clipper might find at Europa that would kind of stymie this theory or kind of put brakes on it slightly? Anything we can envision?
Well, it could be that I could imagine some cases, but I think they're a little contrived. We could find that there are no access points to the ocean. We
Right.
don't find any plumes, for example. We don't find any place where the ocean comes up very close to the surface, where it's more accessible, or that those places um, um, exist, but they're always opening and closing, and they're not very permanent for
Right.
a time scale to imagine designing and launching and sending a mission to them. Is you go to the place that was active back in 2030 or 2032, but it's not
Right.
active in the 2040s or 50s. So you could imagine that. You could also imagine that we found that the ocean water is toxic, unlike the Enceladus ocean water.
Right.
I suppose there are other ways, but I'm more of an optimist on this. I'm excited to see what we do find. And my bias is that we'll find something wonderful about that ocean that will send us back to Europa, if not once, many times, to explore that ocean. We'll see.
Yeah, I mean, I was excited before, and I am. I just can't wait for 2031 now. I wish it was sooner, but that is the way with exploring these distant planets, I guess. Um, we don't have that much longer, but I just wanted to touch on something completely different because for all your space missions and leading NASA, you've also just become a civilian astronaut, which is
Right.
too incredible not to briefly mention. And if anyone has any questions about what that's like, please do put them in the chat. But
Yeah, that was the
so
most
you became, yeah,
spectacular work experience I've ever had. Was flying to space on Virgin Galactic last November, in the first of what I hope will be many missions to use these spacecraft to actually do research astronomy, the way that we've been using robotic sounding rockets in the past. And I will be flying again on Virgin for NASA in a couple of years. But I hope that there's a lot more of that, and that lots of people in our profession get to actually do research in space the same way that oceanographers go to the ocean and volcanologists go to volcanoes. Um,
yeah.
Space is opening up for planetary scientists and astronomers now to do research there themselves in place of automation and robotics, or maybe I should say alongside the automation and robotics.
So you were there trying to learn about the feasibility of doing science in space. Is that right?
Yeah,
What
that's
kind of things
exactly
would
what
that
it is.
be?
Well, a good example is, we don't know how good the windows are on these spacecraft for looking out to do astronomy. Um, I was the principal investigator on a number of space shuttle flights where we operated astronomical telescopes from inside the cockpit and cabin, looking out at a whole variety of targets from the moon to comets to the inner planets to
Wow.
Jupiter. And we have all those data sets. What we want to do is take the same instrumentation, which is old, but it's still working, and look at the same targets from Virgin Galactic and perhaps someday Blue Origin spacecraft to see if we can do as well. And what we don't know are things like what are the microabrasions that can cause glints or other kinds of imperfections in the imaging that you do? What are the imperfections in the windows that change from flight to flight? What about the film coatings that might get on them from the rocket exhaust? Or the glints that come off the wings of the Virgin Galactic spacecraft. That doesn't apply to Blue Origin. And these are things that we really can't calculate. We really have to go and take data and look. And so I'm a principal investigator of a team that's designed a set of experiments to really ferret that out and see if we can do a good job. And if so, the frequency of these flights and their low cost offer a bonanza for some kinds of research, that we can do it better than we did with the robotic sounding rockets, we hope, at lower cost and greater frequency. And
Right.
if that's true, it's going to be super. Uh, and so we're going to go find out, particularly in this very next mission that's coming up in 2026.
Yeah, it's super exciting. So the benefit of that being is like a space telescope, right? You get to avoid the atmosphere. Is that the main? Is that why it's so
You're
desirable?
above the atmosphere. You have special geometries that give you some kinds of things that you can't do from the Hubble Space Telescope or even the James Webb Space Telescope.
Right.
And some kinds of science that just those two telescopes are too busy to do, and
Right.
that
Okay.
these much simpler spacecraft can give us a access point to the same way that we use airborne um, telescopes to do some kinds of astronomy that you can't do from the Earth and that you can't do from Hubble or James Webb or other space-based assets.
Right.
And
Right.
when you fly on these missions, you get to experience a rocket ride up to very high altitudes, way above the Earth, and see the Earth for yourself from space. And there's nothing that substitutes for that.
Yeah, that sounds absolutely incredible. I am jealous, and I do hope that more people get to do it one day because,
They
yeah,
will.
that sounds pretty life changing.
The
Yeah,
future's coming.
certainly is. Well, I am sorry to say that is all we've got time for. I've been talking with planetary scientist Alan Stern, and thank you so much for joining us, Alan. That was truly fascinating.
Thank you, Will. It's been a blast.
And if you enjoyed at home, as I'm sure you did, please do like, subscribe, and share here on YouTube. I've been Will Triggs for Earth Sky. Thanks for watching, everyone.